So here in chapter 3, we've been dealing with a lot of graphing. We really want to start focusing more so on graphing. We're looking at graphs of two variable equations. So first of all, what is a two variable equation? A two variable equation is literally an equation with two variables. So a two variable equation is an equation with two variables. With two variables, let's say x and y. X and y. We've already seen some examples, like we saw the circle, right? The circle. So for example, the circle is a two variable equation. The circle, when you have like x minus 1 squared plus y plus 2 squared equals 4. This would be a two variable equation. It's a circle. For example, a line. Remember we had like y equals, let's say 5x plus 1, and that's a line. That's a two variable equation. So these are some examples we've already looked at. So we want to get more involved with two variable equations. First we want to define what is a solution point. A solution point to a two variable equation is a point x comma y that satisfies the equation. So any point x comma y that satisfies the equation is called a solution point. Let's take, for example, let's look at the equation y equals 3x plus 1. Y equals 3x plus 1. Notice that the point 1 comma 4 is a solution point, Why is that? Because when you plug in 1 for x, you get an output of 4 for y. Let's actually see that, right? We get 4 is equal to 3 times 1 plus 1. So that verifies that 1 comma 4 is a solution point to this two variable equation. Okay, so solution point is just an ordered pair x comma y that satisfies an equation. So what about the set of all solution points? We're going to call this the graph, the set of all solution points for a two variable equation is called the graph of the equation. So if I write down all the possible solutions points to a two variable equation, I plot those, I get what's called the graph of the two variable equation. It should be singular there. So let's just do an example here. Let's say we wanted to sketch the graph of the following equation, y equals x squared. So here's a two variable equation, right? It has y and it has x. The equation is y equals x squared. So we want to find some solution points. So we're going to make a XY table, a table of values. And here I'm going to plug in numbers for X. And the reason we're going to plug in numbers for X is because we have the Y by itself. So since Y is by itself, we're going to plug in for X. So let's just pick some random numbers. I'm going to pick in some nice numbers, -2, -1, 0, 1, and 2. So basically I'm going to plug those in for X, right? I have -2 squared. It's going to give me 4 for Y. For -1, when I plug that in, I'm going to have -1 squared. That's going to give me 1. For Y, when I plug in 0, 0 squared, it's going to give me 0 for Y. When I plug in 1, 1 squared is going to give me 1. And when I plug in 2 for X, square that, I get 4 for Y. Now, these are our solution points, these ordered pairs. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. These are our solution points. We want to actually plot those in a Cartesian coordinate plane. So let's do that. Here's our Cartesian coordinate plane. Let's make that black. So x-axis and y-axis. So we're going to have, notice the x's are going from -2 to 2 here. So I'm going to go -2 to 2 on the x. And the y's are going from what? 0 to 4. 0 to 1, 2, 3, 4. And here I can plot my points. I'm going to start with -2, 4 here. -1, 1 here. 0, 0 is the bullseye. 1, 1 is here. And 2, 4 is here in the first quadrant. And it turns out there are lots of other solution points. So for example, there are xi's between -2 and -1, lots of decimals, lots of fractions. If you were to have plugged, for example, like -0.5 in for x, you would have gotten an output for y. And it turns out you get something like this. If you put all the points in, all the possible solutions points, they're going to line up and make a nice curve here. So this is actually the two variability equation here. Y equals x squared. Y equals x squared. So this is not sharp here. This is curved. This is curved. This is actually what we call a parabola. Parabola, if you're curious for the name of this. Parabola, the type of shape. You know. Some other important ones. Some important two variable equations. We have y equals x cubed. Let's say we want to graph that. We'll do another table of values. Here we have the y by itself, so we're going to plug in some numbers for x. Let's take -2, -1, 0, 1, and 2. These are nice numbers. If you can plug them in, plug them in. So what we're going to do, we're going to cube these. We're going to take -2 and cube that. We're going to get -8. We're going to take -1 and cube that and get -1. We're going to take 0 and cube that. We're going to get 0. We're going to cube 1 and get 1. We're going to take 2, cube that, and we're going to get 8. So these are some key solution points. And let's make an XY table. So it looks like my x values go from -2 to +2. My y values go 8 to -8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. You got that again. 1, 2, 3, 4, 5, 6, 7, 8. And -1, -2, -3, -4, -5, -6, -7. Scroll a little bit. -8. It's not scrolling. There it goes. So I'm going to plot my points here. I'm going to have negative 2 on the x, negative 8 on the y, negative 1 on the x, negative 1 on the y. We're going to have 0, 0 at the bullseye. We're going to have 1, comma 1. And we're going to have 2, comma 8. And it turns out there are lots of more solution points. There are infinitely many solution points, and they're going to line up to give a curve upwards. And that's on the upper right quadrant. That's the first quadrant. And then in the third quadrant, the bottom left quadrant, we're going to have a curve. Let's undo that. Try that one more time. Curving downwards. Yeah, well, there we have it. It's called y equals x cubed. Now, this is sometimes called the bodybuilder pose, right? Bodybuilder pose. So one arm is up in the air and then the other arm is drooped downwards. All right, that's the cubing function. So be familiar with that. Those are, what, 5 critical points you want to know? 5 solution points. All right, what else? Do another example. How about y equals the absolute value of x? So I'll do a table of values. Since the y is by itself, we can plug in numbers for x. Let's plug in negative 2, negative 1, 0, 1, and 2. So here we're going to take the absolute value of the x. So for y, I'm going to take absolute value of negative 2, which is 2. Remember, absolute values kill off negatives. And absolute value of negative 1 is going to be 1. The absolute value of 0 is going to be 0. Absolute value of 1 is going to be 1. Remember, absolute values don't affect positive numbers or 0. They only affect negative numbers. And absolute value of 2 is going to be 2. So here I have my solution points. I'm going from negative 2 to 2 on the x. And for my y's, notice my y's go from 0 to 2. There are no negatives here, so we're just going to go from 0 to 2. So let's plot those points. First of all, the first point, negative 2, 2. It's this dude here. Negative 1 is this dude here. 0, 0 is this dude here. 1, 1 is this dude here. And 2, 2 is this dude here. And I'm going to connect those. Connect those and we get basically a V. A nice V shape. This is the absolute value equation. Y equals the absolute value of x. Come on, come back. And come on. Thank you. All right, now we can scroll up. What else do we want to do? I guess we want to do another special kind of equation, two-variable equation that you want to be familiar with. How about this example? Y equals the square root of x. Y equals the square root of x. So you have to be careful. You cannot, when you're doing your table of values, you cannot plug in negative numbers for x. You cannot plug in negative numbers for x because you can't take the square root of the negative numbers in the real number system. So the first number you can plug in is 0. And then let's pick 1 because you can take the square root of 1 nicely. Let's pick 4 because you can take the square root of 4 nicely. And then let's pick 9 because you can take the square root of 9 nicely. So first we're going to do square root of 0 to find our first y value. Square root of 0 is 0. Then we're going to take the square root of 1. That's 1. And then the square root of 4. That's 2. And then the square root of 9. That's 3. So I picked my x values really nice to be basically perfect squares. Okay, now let's plot this in the xy plane. So if you look at your x's, they start at 0 and go up to 1, 2, 3 here. No, I'm sorry. That's the y's, right? That's the y's. Those are the y's. Let me erase this. They go from 0 to 9, the x's. 0 to 9. So I'm going to start back here. Here's my y-axis. Here's my x-axis. So my x's go from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? This is 9. This is 4. This is 1. And my y's go 1, 2, 3, 0, 1, 2, 3. And I'll go ahead and plot these points. First starting with 0, 0. Then 1, 1. And then 4, 2. And then 9, 3. And it turns out there's lots more solution points, but you're not dealing with square roots. So for example, if you plugged in 1/2 and then took the square root of 1/2, you get something like here. If I plugged in 2 and took the square root of 2, I get something like here, and so on and so forth. So you're going to get something that looks like this. So be familiar with these 1, 2, 3, 4 key points, right? 0, 0, 1, 1, 4, 2, 9, 3. So these 4 key points. This is called the square root equation. The square root equation. Y equals the square root of x. So I think that's all we really want to mention right now. These are some special two variable equations you want to be familiar with. So we have what? The square root, the absolute value equation, the cubing equation, and what? The squaring equation, y equals x squared. That's 1, 2, 3, and 4. Yes, 1, 2, 3, and 4. So be familiar at least with those.